Okay, so we're going to start this text with the heart of algebra, which includes the introduction to functions. We're going to look at the domains of functions, minimums, maximums, graphing functions. We'll start by just using a simple XY chart connecting the points. We'll also look at graphing with our calculators if you have a graphing calculator. Then we will go into our first type of function, which is the linear functions, which are just graphs of lines. So we're going to be looking at how to graph linear functions, not by using the XY chart, but by finding the slope and either the y-intercept or another point. We're going to be looking at linear regressions, which will be coming up with scatter plots in your practice sets. We're going to be looking at solving linear equations, which should be a review for you guys. Then we're going to be looking at solving systems of linear equations, so given two or more lines, where do they intersect? And then we're also going to be looking at solving inequalities, which we'll do that by graphing. Okay, so let's go ahead and get started. So first we have introduction to functions. So to introduce functions, we are first going to look at two variable data and try to discover any relationship that may exist between the two variables. Okay, so for most of this SAT, you're going to be looking at two variable datas. There are a couple problems that you just have one variable data set. So like finding the means and standard deviation, stuff like that, that's going to be one variable. But for the most part, we're going to have two variables. Okay, so to introduce this, let's look at an example. It says the table below shows the average time spent on social media per day and corresponding cumulative GPAs for a group of high school students. So let's just look over this, make sure we understand. Okay, so this time here is 0, 1, 3, 4, 6, 8, and 10. So that is the average time spent on social media per day. I'm assuming this is in hours. It's not given to us, but that's probably what's happening there. And then we have corresponding GPAs. So for example, someone that spends 3 hours a day on social media has a 4.2 GPA. So it looks like they chose 1, 2, 3, 4, 5, 6, 7 students and got that information. Okay, so number one, what is the GPA of the student that spends 8 hours a day on social media? So we're just looking through here. There's a student that spends 8 hours a day on social media. Their GPA is a 3.2. For most of these, I'm going to include the unit. For GPAs, I don't really know what that unit is, so we're just going to put 3.2. Number two, how much time does a student with a GPA of 4.7 spend on social media per day? Okay, so now we're going to work backwards. We're looking at the GPA of 4.7, and it looks like this person spent 1 hour. Okay, and I'm going to say it's an hour. Like I said, it's not labeled there, but that's what I'm assuming. Okay, number three, what pattern or trend do you see in this data? Okay, so this is probably the most important from this example. You'll see something like this on the SAT. It's going to give you some data and you're going to have to see the trend. Okay, so what that means is, let's just look at the time. As time increases, what's happening to the GPA? Okay, you can see that it is decreasing. Okay, so the trend would be as time spent on social media increases, the GPA decreases. So that would be the trend. Okay, so let's just go into some basic definitions of functions. Let me move this. Okay, so these definitions, it says we can represent two variable data as an ordered pair. Okay, so most of the time we're given ordered pairs. Okay, for example, I'm just looking back at this here. Let's look at the 3, 4.2. So we have two variables here. I'm just going to say the 3 is your x and the 4.2 would be the y. Okay, the first number in an ordered pair xy is the input and the second number is the output. Okay, so in this example, 3 is the input and 4.2 is the output. The domain of a relation is the set of all inputs. Okay, so the domain is your inputs. The range of a relation is a set of all outputs. Okay, how I remember this is it goes in alphabetical order. Domain and the I, so the D and the I and the R and the O. Okay, so the D comes before R, I comes before O. That's how I remember input, output, domain range. Okay, so let's do an example given those definitions. Okay, so it says consider the relations 63:4, 45:1, 59:3, 73:9, 46:9, and 45:9. What is the domain and range of the relation? Okay, so remember the domain is a set of all inputs. Okay, so I'm just going to write out all of the inputs. Now it's a set, so how you write sets, you start with an open curly bracket. Okay, and then I'm going to write out all the inputs. So 63, 45, 59, 73, 46, and 45, which we already wrote, so we don't need to write that again. Okay, close your curly brackets. That's how, anytime it says a set, okay, you denote sets with curly brackets. Okay, range, again, we're going to do the same thing, just now it's the output. So 4, 1, 3, 9. Again, we don't need to write 9, so we're actually done there. Okay, number 2, find the output or outputs corresponding to the input of 45. Okay, so we just need to write down the outputs corresponding to an input of 45. Remember, the input is the first number in the ordered pair. So here we have an output of 1. Let's check, make sure we don't have another output, and we actually do, 9. So 1 and 9. Okay, so that's just an example using those simple definitions. Okay, next definition, it says a graph of data points is called a scatter plot. Okay, so we can, for example, just looking back at this, we could graph these with our ordered pairs, which this should be a review for you guys. This relation, we could graph those, okay, just on our coordinate plane. Okay, and that's actually what we're going to do with the time and the GPA. So it says, draw a scatter plot for the below table. What trend or pattern do you observe from the data? Okay, so I'm going to make this the input, this the output. Okay, because it's a horizontal table, I had to actually say I want this to be the input, this to be the output. If it was a vertical table, the one on the left is the input, the right is the output. Okay, so let's go ahead and just draw axes over here. This is going to be my x-axis, this is my y-axis. Again, this should be a review. I'm not going to spend too much time on this. X's, I just need to go from 0 to 10, so I didn't even need this part. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go a little bit farther. 10. The y-axis, I need to go to at least 4.8, so I'm just going to go to 5. 1, 2, 3, 4, 5. Okay, so we have 0, 4.8. So about here, we have 1, 4.7. So about here, this is obviously an estimate. 3, 4.2. 4, 3.6. So about here. 6, 1, 2, 3, 4, 5, 6. We have a 3.3. 8, 1, 2, 3, 4, 5, 6, 7, 8, 3.2, and 10, 3.2. Okay, so there you have that. That's our scatter plot. And then we have to answer the question, what trend or pattern do you observe from the data? Okay, again, you'll see something like this on the SAT. Okay, it may give you a scatter plot, it may give you a graph, and you'll have to see the trend. We normally look at, as x increases, what's happening to the y's. Okay, so I'm just going to write as x increases, y is, you can see it is decreasing. Okay, so as x increases, the y values are getting shorter. Okay, so you can see we're decreasing here. Also, it says, what does the pair 4, 3.6 represent according to the data? Okay, so 4 is the input, 3.6 is the output. So this would be a student who spends 4 hours a day on social media, has a 3.6 GPA. Okay, so that's just making sure you understand that these ordered pairs normally have a unit or value attached to it. Okay, could just be x, y. Okay, bottom of page 2, you see there's an extra graphing scatter plots and a graphing calculator. Okay, so we just graphed these scatter plots by hand, okay, which is fine. This was probably easier to do by hand because we have small numbers here. If you have a graphing calculator, these are actually more accurate. So I suggest using graphing calculators, especially if the numbers are larger. So again, this one was probably easier to just do by hand. But like if we were graphing this scatter plot here, this, you know, you can see these numbers, especially the inputs are larger, so it's harder to graph. Okay, so only if you have a graphing calculator, you'll need to watch this. If not, just go ahead and mark this part out in your text and skip ahead. Okay, so if you do have a graphing calculator, let's just go ahead and graph this scatter plot here. Okay, so go ahead and turn your graphing calculator on. Okay, the first step is going to stat. So let's go ahead and write that down. So over here, you need to press stat. Okay, edit is already highlighted. That's where we want to be. So go ahead and press edit. You shouldn't have anything in this if your calculator is new. Alright, next we need to clear these lists, so you can see that mine is not cleared. So go ahead and highlight L1. Okay, that means list 1. I'm going to go ahead and write down clear lists. Okay, this is really important. If you don't clear lists, I've seen students before, they will just, which I need to show you how to do that. They will just go through here and press 0. Okay, you can't actually do that. Okay, that gives you extra points that you don't need. So you have to clear the list. Okay, so what you do is you highlight L1 and you press clear. That's all you need to do. Go ahead and press down and it should be clear. So I'm going to do that again. I'm going to highlight L2, press clear here, and go down. Don't use the delete button. If you use the delete button, it's going to actually delete L1 and L2, which you don't want that. Okay, so now we're just going to put in our numbers for these lists. So this is our XY chart. Okay, so list 1, I'm going to use the X's. So 0, 1, 3, 4, 6, 8, and 10. Okay, so what I'm doing here is I'm just pressing the number and then pressing enter. Okay, over to L2, I'm going to put the GPA in. So 4.8, 4.7, 4.2, 3.6, 3.3, 3.2, and 3.2. Okay, so there's our list. Alright, now what we need to do next is, you can see above the y equals, there's a stat plot. So there's where our scatter plots are going to be. Let's go ahead and go to second. Okay, so that means the blue. So we're going to the blue. Okay, so we have stat plots here. So you need to turn plot 1 on. So I'm going to go ahead and write that down. And that was second. And then we used the y equals button that gave us the stat plot. Okay, so we need to turn this on so you can see all of mine are off here. So first of all, let me just go over what this means. So plot 1 is off. Oops, I'm sorry. Second y equals. Okay, notice it says L1, L2. Okay, and that's where my list is. Now if I wanted to do another plot, I could go to L3, L4 and change that. Okay, you would change it by pressing enter here. Okay, I'm going to turn it on because I want it to be on, so it'll graph it. Again, you could change your X list to L3, L4, L5, whatever you have them named. Here you have a type. So I just want a scatter plot. I just want the points where it's at right now. This one it would connect the points. We don't want to do that. These are going to be box plots, and we don't want to look at that. We actually won't look at that in this text at all. So it looks good. Make sure it's on. Next, we need to change our window. Okay, so I'm going to go ahead and put change window here. Okay, so I just pressed window. This is kind of how we set this window here. So I went from 0 to, I think it was 10, and 0 to 5. And I'm just going to do that. I'm going to keep it there. So my X minimum, which was here, is 0. My x maximum, I went all the way to 10, so I'm going to leave at 10. My y minimum was 0, and my y maximum was 5. Okay, you could also just use your list. Okay, so x minimum is 0, x maximum is 10, y minimum 3.2, but you want to use 0, and the maximum was 4.8 or 5. Okay, so there's our window, and the last step is to graph. Okay, let me just show that, because now we're done with the steps. Okay, also go into your y equals. So this is where you would graph. So if you've used this before, you'll want to clear out your graphs. So go into y equals, make sure, I just press y equals, make sure this is clear. Okay, so go ahead and graph, and you can see you have a scatter plot, which looks almost exactly like this, except a lot more accurate. Okay, so that's how you graph scatter plots with your graphing calculator. Okay, on to page 3 of the text. We're going to go into another definition. It says a function f is a rule that assigns to each input exactly one output. Okay, so we've seen a relation before. Okay, going back to page 2, here's a relationship or a rule. This says 63 goes to 4, 45 goes to 1, 59 to 3. Okay, you can read those. But it has an extra part. It says it assigns each input exactly one output. Okay, so each input just has one output. So this wouldn't be a function. Okay, because 45 goes to 1, 45 also goes to 9. So this input of 45 has more than one output. Okay, for functions, so once you've established you have a function, you can use the following notation to describe a function. So we use f of x equals y. F is the function name, so we can change this. I normally go f, g, h, but we'll look at numerous names. X is the input value, so your input is always the variable inside the parentheses, and y is the output, which again we can use different numbers for that. Okay, so this is, we input an x value, you apply f to that x value, and then you get out y or f of x as our output. Okay, so we can write x goes to f of x. Okay, so we'll look at some examples. First of all, let's see if these are functions. So is the relation 63, 4, 45, 1, 59, 3, 73, 9, 46, 9, 45, 9 a function? Which we already established that was no. And that is because 45 goes to 1. So when you input 45, it goes to 1. And when you input 45, it also goes to 9. Okay, from this information here. Okay, so we have an input value that has more than one output. Okay, so that is not that. Okay, next example, are the relations given in the tables below functions? Okay, so x is our input, y is our output. We just need to look and make sure we just have one input here. Okay, so looking through here, we have 31, 22, 24, 35. Nope, 31. Okay, so this would be no. 31 goes to 3, and 31 goes to 2. So that is not a function. Next one, we have 31, 22, 24, 35. These are all different, so this would be yes. Okay, notice the output values are all the same. That's okay. Okay, so as long as each input just has one output. So if we were to add in maybe a 31, 4, then that would make it not a function. Okay, so this is a function. Okay, next definition, bottom of page 3, it says the variable y is a function of the variable x if each value of x, which is the input, corresponds to exactly one value of y, which is the output. Okay, so this is basically the same definition we just looked at, except we have some variables here. So it says y is a function of a variable x. Okay, we shorten this and we say y is a function of x. Okay, so we'll see this. Y is a function of x, or x is a function of y, or time is a function of GPA, or GPA is a function of time. Okay, so you'll see something like that. Okay, so in the above case, x, which was the input, is the independent variable, and y, which is the output, is the dependent variable. Okay, so remember input is, that means goes to. Input is the same as independent spelled that wrong. And then the output is your dependent. Okay, and this is easy to remember because the ions go with the ions. Okay, so on to page 4, we're going to do some examples. Okay, so it says for the below table, is y a function of x? Is x a function of y? Alright, so first of all, we need to break down this definition. So the first one, y a function of x. So let's go ahead and write that one down. So y a function of x. Okay, so we need to figure out our input and our output. Okay, if we go back to the bottom of page 3, this is exactly what the definition was. With x as our input, or independent variable, y is our output. Okay, so let's write our table value like that, which we already have it written like that, but let's just go ahead and write it again. So x is 1, 2, 3, 4, y is 3, 3, 3, 3. Okay, so is this a function? Yes, it is. Okay, we can see that it's a function, okay, because each input has just one output. So this would be yes. Okay, the next part of the question, it says, is x a function of y? Okay, so now we have to go backwards with our definition, which would mean, looking back on page 3, the y is the input and x is the output. Okay, so x a function of y. Okay, so y is our input, so it's going to go on the left. X is the output, so it goes on the right. Alright, so y is, looking back at this, is 3, 3, 3, 3. X is 1, 2, 3, 4. Okay, so is this a function? No, because 3 goes to numerous outputs. And I'm just going to write down 3. So no, because 3 goes to 1 and 3 goes to 2. Okay, so that answers that question. Next example is a lot like this one. So it says there's 1, 1, 2, 4, 2.5, 6.25, 3, 9, and 2, 6. Define y as a function of x, or x is a function of y. Okay, they both could be yes, they both could be no, or one yes, one no, like up here. Okay, so let's go ahead and do y as a function of x. So with y as a function of x, we have that x is the input and y is the output. Okay, so we're not given a table, but we are given points, so we're just going to write out our points. Remember, the first value in ordered pair is always the x, the second value is always the y. Okay, so let's write our x's first. Those are the first values in an ordered pair. So 1, which I'm going to have to write small here, 2, 2.5, 3, 2. And the y's are 1, 4, 6.25, 9, and 6. Okay, so is this a function? No, and it fails at 2. So this would be no, because 2 goes to 4, and also 2 goes to 6. So that is not a function. Okay, other way around, x, a function of y. Okay, so here y is the input, x is the output. Okay, so now we're writing the y values, or the second variable in our ordered pair. So 1, 4, 6.25, 9, and 6. And then our x's, 1, 2, 2.5, 3, and 2. So is this a function? Yes. Okay, so yes, every input has just one output. Okay, next example, we're actually going to be looking at function notation here. So it says, consider the function g of x equals 8x. Number 1, what is the name of the function? So remember, that's just the letter here, which in this case it is g. So g is the name of the function. Number 2, what letter represents the input? So remember, the input variable is the variable inside the parentheses, which you can see is x. Number 3, what letter represents the output? Okay, so we have the output is actually g of x. So remember that x goes to g of x, or you write something like this, x goes to g of x. Okay, so input x, output g of x. So output would be g of x, or you can write 8x. Okay, you can see that they're equals. We set those equal to each other. Number 4, what rule does this function represent? Okay, so you can see it says to take the input value and multiply it by 8. Okay, so that's the rule. We can actually say what the function means. So multiply the input by 8. And number 5, find g of 2. What does g of 2 represent? Okay, so g of 2 tells us we want to input a 2. Okay, so when we input a 2, that means the rule says to multiply the input by 8. So that means we're going to take 8, multiply it by 2, which is our input, which is 16. Okay, so g of 2 would be 16. As an ordered pair, we would write input, comma, output. Our input was 2, our output was 16. Okay, so that's what that looks like as an ordered pair. It says what does g of 2 represent? So in writing, I'm going to put a little box around this. 16 is the output when the input is 2. Okay, again, input 2, output 16. Okay, bottom of page 4, this is just again working with some function notation. Okay, it says express y equals 4 plus 2x in function notation, where x is the independent variable. And then it says express y equals 4 plus 2x in function notation, where y is the independent variable. Okay, so remember independent variable means the input. Okay, so we want the input to be the x first. Okay, so I'm going to put x as independent, or input here. Okay, and we want this in function notation. Okay, so instead of y equals 4 plus 2x, let's just name it f of x equals 4 plus 2x. Okay, let's just check, make sure this is correct. Okay, x here is the input. Okay, and the whole function is in terms of x. Okay, so we could choose some input. Let's just, for example, do f of 1. So we'd input 1. This would be 4 plus 2 times 1, which is, what, 6? Okay, so our ordered pair would be 1, 6 here. Okay, that was just an example, not part of the problem. Okay, now we want to express y equals 4 plus 2x in function notation, where y is the independent variable. So y as the independent, or again, input. Okay, so we have y equals 4 plus 2x. Now we can't just name it f of x here, because then that would be x as the input. Okay, so we really need to solve for x so we can have y as the input, or have like an f of y, or I'll probably name it g. Okay, so let's solve for x. Subtract 4, y minus 4 equals 2x, and then divide by 2 on both sides. I'm going to go ahead and switch my x. I'll leave it the same actually. So we have x equals y minus 4 over 2. Okay, so now we can name this instead of x. We're going to have that as our function. And again, I'm going to use g's just so it's different. So we'll have g of y equals y minus 4 over 2. Okay, let's check this. Y is the independent variable. It's inside the parentheses. That means it's the input. And our whole function is in terms of y. Okay, if we had g of y equals 4 plus 2x, that wouldn't make any sense. Because if you would input a y, you wouldn't know where to put it up in this. Okay, so let's check again with like, let's do 4. That one looks easy. So let's do g of 4 here. That would be y needs to be 4 over 2. That's 0 over 2, which is 0. Okay, I know that's kind of messy there. That's just an example. Okay, on to page 5. It looks like we're almost through with function notation here. So top of page 5, another example. It says let f of x equals 3x squared plus x. Evaluate the function at the given points. So let's do f of negative 2 first. So that means to input negative 2. When we input -2, our function tells us to take the input, square it, then multiply by 3, and then add the input. Okay, notice it looks exactly like this function I just wrote, but instead of x, I've got the input value. Okay, -2 squared is positive 4 plus -2. That is 12 minus 2, which is 10. Okay, so if I were to write this as an ordered pair, that means input -2 and our output is 10. Okay, next, f of 0. So again, we're squaring the input, multiplying by 3, and then adding the input, which is actually a little bit easier because everything just goes away. So we have 0 plus 0 equals 0. So point, we would have input 0 and the output is 0. Okay, let's do one more example. So it says if a computer weighs 12 pounds on the surface of the earth, then the weight of the computer h miles above the earth is given by the function w of h equals 12 times 4025 divided by 4025 plus h squared. It says evaluate w of 100, and what does your answer mean? Okay, so before I do any word problems, I like to, especially if you're given a function, go ahead and break this function down. Okay, so let's just write down what we know. The name of the function is w, which we don't really need that. Our input value is h. Okay, that's always the variable inside the parentheses. So let's just look back, and it says h is in miles. Okay, so I'm just going to put it in parentheses. H is miles. Okay, what is the output? That is w of h. Okay, that says the weight is given by this function. Okay, so that's going to be weight. And it also gives that in pounds. Okay, so I'm just going to put pounds here. Okay, so this means for this function, you're going to input a number of miles, and you're going to output pounds. Okay, so you can pick a number of miles, and then it's going to give you a weight. Alright, so it says evaluate w of 100. What does your answer mean? First of all, this 100, that's our input. So we're inputting 100 miles. Okay, so if you travel 100 miles above Earth, we're going to get our output, which is given here. Okay, so w of 100 equals 12 times 4025 over 4025 plus h. Okay, which here our h is 100 squared. Alright, we definitely need our calculator for this one. Clear out that scatter plot. So I'm going to do the fraction first. Remember your order of operations. So you want to start with, here we have an exponent, but you need to evaluate the fraction and then square it, and then we'll multiply by 12. Okay, we could do this all in one step. I'm going to do it in a couple steps. Okay, so we want 4025 divided by, open your parentheses here. Okay, so 4025 plus 100. Okay, if you don't do that, so I'm going to go ahead and evaluate that. If you don't do that, your calculator is going to use order of operations. Okay, so it's going to do division first, and then it's going to add 100. Okay, you can see it's way off. Okay, so again, make sure anytime you have an expression, okay, meaning you have addition, subtraction, multiplication, division, in your numerator, your denominator, you put them in parentheses. Okay, if you just want to be safe, put everything in parentheses. Okay, so put your numerator in parentheses, put your denominator in parentheses. Okay, so there's that number. Okay, we have our fraction down. Now we need to square it. Okay, I'm going to use the caret button. That's normally what I use, so that means answer squared. Okay, so it's taking this answer and squaring it. Enter, and then the last thing we need to do is take our answer and multiply it by 12. Okay, you can do this differently on your calculator. I just wanted to show you how I would evaluate this. Okay, which I got about 11.43 approximately, and this was in pounds. And we want to see what that answer means. Okay, so the output represents how many pounds, or the weight of this computer. Okay, so we would say the computer weighs 11.43 pounds when it is 100 miles above the surface. I'm running out of room here. Okay, we could also write this as an ordered pair, so it would be 111.43. Okay, so we're going to go ahead and stop there, and we will pick back up on middle of page 5. We'll start with the domain.